Thousands of people are trying to enter the AI space right now, but the sheer volume of new tools and research papers launching every week makes the entry point feel impossible to find. Most beginners fall into tutorial hell, where they learn to write isolated Python scripts or solve calculus problems without ever understanding how those pieces connect to a functioning large language model. This timeline is the Build Club's 60-day journey. It serves as a bridge, taking you from a blank terminal to a deployed, production-ready application in exactly 2 months. Every phase of this roadmap requires a specific deliverable. You move from building basic calculators to training neural networks, ensuring that you have a functional portfolio piece for every week of study. Mastering these systems is the result of executing a structured sequence of increasingly complex milestones. The first 15 days focus on Python and object-oriented programming, the basic syntax needed to give machines precise instructions. You use libraries like Pandas and NumPy to clean and organize raw data, which provides the necessary fuel for any model you build later. This is where you build your first major project, a structured dashboard that takes thousands of disorganized Netflix data points and visualizes them into clear trends. From day 16 to 25, the RoadNet shifts into the mathematical engine room. Every AI model relies on advanced pattern matching, which is governed by the rules of linear algebra and calculus. You study Bayes' theorem, which is the specific mechanism machines use to update their internal probability calculations as they receive new evidence. Understanding this math prevents you from treating AI like an unpredictable black box and allows you to debug models based on logic rather than guesswork. Between days 26 and 40, you combine that code and math to train your first machine learning algorithms. You implement models like random forests, which can analyze historical data to predict future outcomes. This phase ends with the construction of a house price prediction tool, a functional application that calculates real estate value based on market variables. Phase 4, covering days 41 to 50, introduces deep learning, where the goal is to give machines visual comprehension. Using frameworks like TensorFlow and OpenCV, you build convolutional neural networks that process raw image pixels to identify specific objects. By categorizing these visual patterns, you can deploy tools capable of identifying plant diseases or detecting face masks in a live video feed. Linking these predictive algorithms with computer vision allows an engineer to build systems that interact with the physical world, rather than just static spreadsheets. From day 51 to 57, you move into generative AI to build models that can simulate human reasoning. To make these models accurate, you use Retrieval Augmented Generation, or RAG, to ground their responses in specific, verified data. The model pings a vector database, retrieves necessary context, and generates a factual response. This creates an autonomous knowledge-based chatbot to answer questions about private documents. But models need to be accessible. The final 3 days focus on deployment. You package your application using Docker and build a web interface with Streamlit to move your code from a local laptop to a live cloud environment. This final step translates theoretical knowledge into a tangible product that users can actually interact with. By day 60, the overwhelm of the first week is gone. You now have a portfolio containing OCR analyzers, predictive ML models, and RAG chatbots. This 60-day foundation provides the technical baseline for specialized careers in MLOps, natural language processing, or computer vision. While these systems are complex, they are built on a series of logical steps that can be systematically learned. Entering this field requires 60 days of disciplined, project-driven building to gain the skills used by today's leading tech companies.